In our previous tutorial introducing categorical logic, I used an informal diagramming system, I guess you could call it, that represented the subject and predicate terms and the relationship between those terms. So what we want to do is refine that informal system so that it's a more powerful system. And one of the ways we can do that is by having the diagrams start from the same empty schema. The diagramming system that I'm introducing right now was invented by Venn, and so these are they're called Venn diagrams. You've probably encountered Venn diagrams at some point, but there are a few idiosyncrasies about Venn diagrams in a logic context that you want to pay special attention to. So first of all, one of the things we noticed about the particulars is if you diagram only the information that is provided in the claim, so the claim is sum S is P, then notice because we're using these overlapping circles to give us three different regions so that we don't have to assume any information that isn't given in the actual claim. So the claim is sum S is P, as I mentioned. We have three regions to look at. We have the region of S outside of P. Those are all the S's that are not P's. We have the region of P outside of S. Those are all the P's that are not S's. And then we have this overlapping region in the center that will have S's that are P's. Notice in the proposition sum S is P, the only claim that's being made is that there's at least one S that is a P. So we want to indicate that by putting a little X in the region of S that overlaps with P, and this X indicates the at least one. So what that X shows is that there's at least one S that is also a P. Notice in the original proposition, the assertion is at least one S is a P. It doesn't make a claim about whether there are or are not S's that are not P's, and it doesn't make a claim about whether there are P's that are not S's. But we need to leave the possibility open that there might be S's that are not P's or P's that are not S's. And so in order to show that possibility but without taking an actual stand on it, we use a diagram that allows us to have this open and empty space in the region here, the S's that are not P's, and the region here. Similarly, for some S is not P, we want to use a diagram like that with the possibility that things could occupy these regions, but without taking a stand on it. And the reason is because the only thing that's actually asserted in this particular negative is that there is at least one S that is not a P. So we put an X to indicate the S that is not a P. But notice we don't make any marks in the central region, the overlap, and we don't make any marks in the region of P outside of S because, again, we're not given any information about that. So we can't take a stand on it, right? So now think about this. It will be most convenient for us in terms of comparing diagrams and trying to understand what the diagrams mean if we keep the basic form of the diagram stable across all the different types. So in a previous discussion, I actually used an informal diagram that put the set of S's completely inside the set of P. I think we used the example of all cows are mammals, right? So the set of cows, the circle that represents cows, was entirely inside. But notice this diagram, even though it shows the proper relation between S and P, it's harder to compare with the diagram that is overlapping down here. So what we do instead is we use an empty diagram. We'll call it the schema of the diagram. The empty diagram is always going to be the two overlapping circles. Now we have a problem. That problem is, how do we indicate that all S's are P's. We could put a bunch of marks in the overlapping region, but that might not, it would be ambiguous because it might still suggest that there could be things in the region of S that are outside of P. So the convention that we'll adopt is to use shading, and we'll agree that shading means empty. So in this particular case, shading, I'm going to use some blue to shade. The shading in this region means that the area of S outside of P is empty. So remember, shading means empty, right? Now, look at where that shading is. You will see that the shading now actually makes basically the same diagram as this informal diagram, except now it's much easier to compare between the universal diagram and the particular diagram because they start with the same empty scheme. Okay, so how's this going to work for universal negative? Well, we're going to start with the standard empty scheme, not very well drawn. We're going to use, in this case, we'll go back to blue, we're going to shade the region in the middle here to indicate that there are no S's that are also P's, which is exactly what the proposition claims. So now notice, because of the shading, we've actually ended up with a diagram that looks like the informal diagram I drew about cows and reptiles, which is the two sets, one for the subject, one for the predicate, not overlapping at all. They have no common members, right? So they're excluded from each other. But the shading accomplishes exactly that exclusion for us because it says that the region of S overlapping P must be empty. And because it's empty, then everything that is an S is outside the region of P, and that accomplishes exactly what this informal diagram accomplished. So as I have gone through this sort of intuitively, what we've come up with is a diagramming system that has these steps. So step 0, we're going to use the empty scheme, and that's going to be two overlapping circles with the subject term and the predicate term in the order that they appear in standard form. So subject, predicate, right? Step 1, we're going to use shading to mean empty. And step 2, we're going to use an X to mean at least 1. So you will notice that for these universals we've shaded. Notice that only universals get shading because only universals tell us something about all the S's there are, right? And when we have particulars, at least at this stage of our discussion, the particulars have X's to indicate the at least one. And we only need one X here in the middle because this assertion actually tells us, for instance, in the affirmative, at least one S is a P, and it leaves all the other possibilities unaddressed.